If you are a web developer working with JavaScript, you might have faced these problems. Suppose your website is downloading a huge file, or maybe it's uploading some important data, or maybe it's just loading some 100 megabytes of JavaScript file that just animates a progress bar that you absolutely do not need. Or maybe you are processing some long-running job and you have to wait until they finish. Now these jobs might succeed or might fail, and accordingly you have to proceed. Now all of these tasks should be asynchronous and they should happen in the background, because you do not want the UI to stop responding. Unless of course you are creating a government website. In that case you do not give an F about usability. If you have run into these situations before, you might have used callbacks, where you would call a long-running function and pass another callback function that would be run after completion of the job. Now in most real case scenarios, these callback functions would also trigger another long-running job, which has another callback, and soon you'd be in something like this, which is known as callback hell. Those days are over, because promises are here. The days of crying over callback hell are over. It's now time to cry over promise hell. Now promises are like the millionth attempt at fixing JavaScript, and you can be rest assured that it in fact does not fix JavaScript. But it's still useful because it's slightly more manageable than callbacks. Now promises can be intimidating at first, just like everything else in JavaScript. But within 5 minutes of watching this video, you will know just enough you need to search about promises on Stack Overflow so that you can solve your own problems. Now promises are so overpowered that they had to introduce async await, which is just a normal synchronous code with some extra steps. Now promises in JavaScript are just like real world promises, where someone makes a promise and they either fulfill it, or if they are like me, or maybe they are politicians, they just reject it. So a promise starts by defining an instance of the promise class. Now a promise can be in 3 states. It can either be pending, which is the initial state. It can either be fulfilled, which indicates that it's successful, or it can be rejected, which means it was unsuccessful. The last 2 states together are sometimes called the settled state. Now a promise that was fulfilled cannot be rejected, and a rejected promise cannot be fulfilled. But you think you can break your promise and try to fix it afterwards? That's not gonna work. Now currently our shiny new promise is in a pending state. However, we have not defined what it should do yet. So let's do that. The promise constructor takes an argument, one function, which is the executor function. This is the function that is run and performs a long-running job. Now it is run in the background. You can assume that it starts running as soon as you define the promise. So in reality, this is not the case, but I do not want to go into the details of event loop and all, because let's be honest, nobody knows how JavaScript works. The executor function itself takes 2 arguments. Now traditionally they are called resolve and reject. These 2 are functions which are supplied by the runtime. So basically to create a promise you have to call a function that takes as argument a function, which again takes as argument 2 functions. This is not confusing at all, because you'll copy your code from Stack Overflow anyway. The executor function performs an operation which might be successful or might be a failure. Depending on the result, you will call either resolve or reject. So if the operation is successful, you call the resolve function and pass as argument the result that you want to return. Think of it like returning a value but with some extra steps. This result can be anything. It can be a number, a string, boolean, or even a JavaScript object. Here I passed 0, which is my IQ point. Now calling resolve stops execution of the function and the promise goes to the fulfilled state. On the other hand, if the operation is unsuccessful, you call reject and pass it a reason for failure. Again, this can be anything like string or object, whatever makes sense to your case. It's often a good idea to pass an error object because they capture a stack trace. you can trace an error to its origin. Most often, you will find the root cause is your decision to use JavaScript. What are you going to do? Use Java? Now that a promise is created, how can you wait for it to finish and get the result back? Well, you call the then method on the promise object and pass two functions to it, which is basically just two callback functions, but let's call them handler. What? You thought you got rid of callbacks? Nope. The first argument is the success handler and the second argument is the failure handler. The first function is called when the promise resolves. It takes one argument. This argument captures the value that was passed to the resolve function. If you remember how our promise was defined, you will see we pass 0 to the resolve function. And so result gets the value 0. Easy. Similarly, the second function is called when the promise rejects. It also takes one argument, and as you can guess, the argument captures the reason that was passed to the reject function. You can also pass only the success handler to then and put the error handler in a separate method called catch. This does the same thing with a minor difference that you will see later. Now you do not always need to handle success or rejection. It's perfectly valid to omit them or just pass undefined in place of the handlers. Now remember that while an unhandled rejection is not an error in places like Node.js, in future it will be, so be mindful about that. The then method actually returns a promise itself. Now this depends on what the success handler inside then returns. If the success handler returns a value, the then method returns a promise, which resolves with the returned value. This means you can chain multiple then calls. Here the first then returns a promise that resolves with some other value. So the second then is called with result2 being equal to some other value. The handler can also return a whole promise object. Now in this case, that returns a promise that resolves or rejects according to the returned promise. So in this case, then returns a promise that resolves if another promise resolves, and with the same result. So result2 will be equal to whatever result another promise resolves with. And if another promise rejects, the promise returned by then also rejects. Now remember that if the handler does not return anything, then method still returns a promise which resolves with undefined. Now this is where using a catch method differs. Here the first error handler fires if getIQPromise rejects. And the second error handler is called when the promise returned by the first then rejects. As you can see, this way helps us catch error immediately. But remember that if you handle an error early, you have to make sure the next promises in the chain know what about the error state. So if the getIQPromise rejects, the first error handler will be called. And if it does not throw an error, the returned promise will be resolved. And the next chains will not know about the error, which can cause bugs later. Now it's better to use a catch at the end, but it does not do immediate handling. So this handler is called when any one of the 3 previous promises reject. So it's like a catch-all type of thing. Now as for a somewhat practical example, consider this hypothetical database call where you want to find the user by his name. Now database calls are time consuming, and so this method returns a promise. So you can chain a then method which calls the handler with the resolved user. Then you do something with the user like taking all his money. And you save the updated user back to the database, which again returns a promise. And you return this promise. So now you can chain another then, which resolves when the user has successfully been saved. And finally you have a catch method that fires whenever any one of the promises reject. Now there is also a finally method which is called whenever a promise has been settled. So if you have been paying attention, you will remember that a promise is settled when it's either rejected or resolved. So finally is called regardless of whether the promise is resolved or rejected. Now note that the handler of finally does not take any argument. Now let's see how you can handle multiple independent promises. Depending on your use cases, there are 4 methods. For this example, let's say the first promise resolves with 1, the second promise rejects with a string error, and the third one resolves with 2. The first method is promise.all. Now it takes as argument, which should be an array of promises. This method returns a promise which waits until all the promises has been resolved or any one has been rejected. The key thing to note is that any one rejection will reject the entire promise. Now this new promise resolves when all the promises resolve, and it resolves with an array of all the resolved results, and it rejects if any one of the promises reject, and with the reason that this rejected promise returns. So in this case, the second promise rejects with reason, which is a string error. So the new promise also rejects with the string error. Easy, right? The next method is called promise.allSettled. This always resolves no matter what the individual promises do. So it waits until all the promises are settled, and then it resolves with an array with the result of the individual promises. Note that the result stores if the individual promises have been fulfilled or rejected, and also the values if it resolved, or the error if it rejected. The next method is promise.any. This one returns a new promise which waits until any one resolves and resolves with the same value. Now if all the promises reject, this one also rejects with an error. Now in essence, this is the opposite of promise.all, because promise.any resolves when one promise resolves and rejects if all promises reject, whereas promise.all resolves when all promises resolve and reject if one promise rejects. The final one is promise.trace. It returns a new promise when any one promise resolves or rejects. If it resolves with the result of the first resolved promise, and if it rejects with the reason from the first rejected promise. So basically it's just a race between all the promises, which one can finish first. And finally we have promise.resolve. So it accepts a single argument and returns a promise that does nothing and resolves with the value you just provided, which is same as writing this. So this always resolves with the value you provided. Similarly, we have promise.reject, which also takes one argument and does nothing and will always fail with the reason you provided, which is same as writing this. Now these two methods are useful for debugging mainly, where you want to create a promise quickly. And that's it. Now you can go ahead and solve all your callback hell with promises and introduce new bugs. Good luck.